participado já de vários eventos
I have participated in several meetings of carried out by Fungi Citrus, presenting partial results of biopesticides for controlling greening vector. And now I'm going to talk about this product that is finished in the market already and ready to be used, that is Challenger. It's a pleasure to be here to present about this product and now talk about the history of the development of this product. It started in 2011 when we wanted to develop a product that was fungi based. In the first 2 years of the studies, the results were really promising, and we saw the need for a commercial partner since the beginning of the uh, project to make it viable in terms of production and registration of the product. So during this time, 2014 to 17, we had the participation of the company we chose, that was Koppert, to manufacture the product. And Danilo is here representing this company. He's going to talk some more about the characteristics of this product called Challenger. It's based on a fungi that is called Eisseria fumosorosea, and it was developed specifically for controlling Diaphorina citricellid. So that's the first commercial product based on this fungi in Brazil as well. And so this project is here. November 2017, we had the commercial registration for that product. So we have more recent data on it. So let's first talk about this product. The active ingredient is this entomopathogenic fungi, Eisseria fumosorea, and it's commonly used in Brazilian soils and worldwide as well. It's a fungi that is also found naturally on some mites and other insects like Diptera and Hymenoptera. We have a few products based on that fungi in the world, and they're used to control whitefly and aphids. In Brazil, it may cause high mortality in whiteflies for different crops. So how does that work? Well, it acts initially. There is a phase that we call adhesion until the germination. That is, spores are the conidia, they are the reproductive structures. They have to fall on top of the insect body. Here's the spore germinating on a part of the insect body. And that is an event that is regulated by a series of factors like electrostatic charge of the conidia and insect, hydrophobicity of the surface, until the adhesion occurs for germination. There is enzymatic and mechanical components for penetration of the fungi into the insect. It's usually through membranous tissues. They're tender. And then we have hyphae that colonize the insect internally, producing toxins and causing the death of the insect. That is the colonization phase. And then it has to reproduce, that is to get out of the insect. So that is a phase that is external growth. Then we have here this powdery structure, and that is a signal for citrus growers to use the product. They're going to find insects with this characteristic. So this will generate a new cycle for infection because it produces more conidia on the insect body, not necessarily only Diaphorina, but also other insects like aphids. They're very susceptible to this fungi. So this is a characteristic that is important. It's something that makes a difference for this product. There's no action period as a systemic insecticide, but it has these characteristics of being recycled and generate new infection cycle in the environment. So besides the active ingredient, that is the fungi, the product has a formulation including IMETs, we have adjuvants that will provide the characteristics that are desirable for the insect. And that's what is one of the differentials of this product. In the last 2 years, we have had a flooding of products for entomopathogenic products. And there was a regulation set forth for these products. So we have to see what the norm allows us for registration of the product. So it's very complex for us to develop a formulation. Therefore, to sum up, what is a formulation? What does it have to have? We have to have adjuvants that will provide important characteristics to the product. For example, miscibility, that is, the product has to be able to mix to the water. The canidia is hydrophobic. It won't mix with water, so I have to have a tensioactive substance for that. It has to be suspended, a suspension. It cannot settle down within this liquid formulation. And then spreadability and adherence and all other adjuvants that are added to the product are going to provide it with good characteristics, like protection against the UV light and other environmental factors, and also a good shelf life. So let me talk about the process that we carried out for developing this formulation. First studies that we carried out had results that were not really consistent. We were testing a product that was already in the market and some isolates that we had in our isolate bank. And we had to go back a little bit to better understand the insect and why things were not working out well. This slide shows a mapping of the morphology externally to the insect. Here we have characteristics like, well, insect in its back, the back of the insect is protected by their wings, so it has no good wetting of the formulation to the back of the insects. And we have to have adherence for the product to work. In the thoracic part here and head of the insect, there's a large amount of structures that are waxy. This is the head, and this is water repellent. So wetting has to use some tensioactive substances to break the surface tension of the water so that we can go on with the process of adhesion of the canidia to the surface of the insect body. So if you use electronic scan, we see that this brown area here is shows a very thick layer, and it's chitin here. It's very hard to penetrate, and we understand that this will have also some substance that will affect the germination of the spore. And most of the adhesion will take place in the ventral part of the insect body, the lower part. So how do we solve this problem then? Well, we have a series of adjuvants tested at a lab. Here we have some of them. This is an adjuvant that is very harmless and safe. We use that for other antimicrobials. Here we have the canidia that are unchanged, do not germinate. Some would adhere but not germinate. They would just stay there. That's the tween. The suet that is really good for reducing the mixture volume. It has characteristics that are interesting, but also, likewise, we do not see in this region of the body a development or germination of the spore. And data show that the determination of a certain mixing volume, the retention of canidia is slow. It's a lot of canidia is lost, even if it wets the insect. This is an acronym for the formulation. That is the property of Koppert now. And here we show the canidia already germinated in this part of the insect body. We have done studies like this for other parts of the insect body. So this adjuvant has a additive action, maximizing the action of the fungi. How does the product work? Well, basically, it's a suspension that is concentrated in a liquid form. Here we see how miscible it is. It really mixes fast to the water with no settling down. And it's just like any other chemical product to be used. So those are the characteristics of the product. And now I'm going to show you the data in terms of field application. In the first year, December 2011 and 12, and then until 2013, we carried out some initial tests that basically served to understand the volume of application to be used. This is an area in Itapetininga, in the Recha farm. We used 2,000 liter per hectare with a downward trend for that. So we compared that to 1,000 liter per hectare for Challenger. And also, we wanted to know if it was possible to apply that throughout the year. Results were really promising at the time, showing that uh, practically throughout the years, we had 65 to 96% of mortality, even in the dry season, where we had the reduction, especially here in September, October, a reduction, a slight reduction of inefficacy. But it's the same thing for chemical control. Just 1 month had significant difference as compared to chemical control. So we showed here that the product could be used along the year due to the formulation. So it's a oil-based product, differently from other products that do not have that characteristic. So results were really important and showed that 1,000 liter could be used as a volume. Maybe during the dry season, I could use a little larger volume. That was studied for mature plants, more than 30,000 cubic meter. And here for 2014 15, we tried to implement the product into the management of a farm, both organically and conventionally. We used 2 farms with monthly applications. We also, this is for Taka farm, that is organic farm with a high population present. It was a system where we compared natural populations. The studies before were carried out in Voal. This is, we used a yellow trap, sticky trap or card. And for psyllid, we got good control significantly. 9 hectares were studied in this trial. But what drew our attention was that there was a reduction that was drastic in the leprosis mite. So here, significant result. Here, leprosis. And then in green, we have the Challenger applied. Also, we can see that in the pictures. This is an area for the application of Challenger, and here the conventional organic management of the farm. There was a fruit drop that was interesting to be seen. Growers were really interested in getting the product to be used. And here, this is a different farm in Nova Europa, São Paulo. And here we have the control, chemical control, and the control with Iceria. And the Challenger had these results with a lower count of mite. Here I'm showing the rust mite. And in 2 peaks here shown, we can see numerically in green where we apply the Challenger with a lower number of, as compared to chemical control and the non-treated. We have here the natural enemies, and for Taka farm, we had a high population of a natural enemy, so there was no difference for chrysopides and Hemerobidos and ladybugs. So there was no toxicity for natural enemies whatsoever. So also we have data for Tamarixia, as Paha mentioned. We have tests, and we studied the selectivity for Tamarixia. Another data that I'll present, we have a recent data for this semester in a trial carried out with Fundicitrus and Koppert. We sprayed 10 regions in the state of São Paulo and 1 in northwestern Paraná. And this is the average figures for all those areas. with the control of 38.5% first day, 64 fifth day, and 82% 10th day. Very significant results, especially if we consider that some spray-ins were not didn't result in good control. We cannot rule out problems in terms of fungicide residue, or but especially for two areas at least, growers used spraying volume well below the recommended level. We recommend 60 ml per cubic meter, and we have studies with the possibility of reducing that, even especially for younger, smaller grows. But those lower results here were due to lower volume of application. And that is considering diverse climatic conditions in different areas, in different times of the day. So some people say the fungi will only work if we use night application, colder areas, and it's not really the case. So the product can be used different ways within the areas. So this is all I'd like to say. I'll now invite Danilo to talk further about some characteristics of the product. Talking a little bit about the product, it's an insecticide that is microbiological, registered under or for plant protection as a conventional product. Just like agrochemicals, we have the biological products together in the same file. We have the mode of action is the contact action. So that's why we reach the target, and that's important to have the right volume of application and technology. The active ingredient is the fungi, the Iceria, and the line is Esalq 1296. Yes, there is drastic difference and very basic when we compare lines of microorganisms. And a simple analogy, it's just like human beings. We are all Homo sapiens, but we all have our differences. Microorganisms are not different than that. Formulation is a concentrated suspension. And again, the organism is not soluble in water, it's miscible in water. So this proprietary formulation has many adjuvants that will provide not only survival and mixing property, but also fast penetration of the microorganisms after germination into the insect body. And it's registered under the Department of Agriculture since last year. As benefits, of course, we have the control of psyllid. It's the first bioinsecticide that is specific for controlling psyllid in the world. This product is initially launched in Brazil now, and then it's going to be launched worldwide, and it's being registered in many countries already. We have the management of resistance and additional control for leprosis, mites, and other organisms that are target but are called secondary. Reduction of residue in fruit, absence of interval of wait. We don't have to wait in between or after the application. And then we have the preservation of natural enemies and pollinating agents. So zero waiting period. So we preserve those natural enemies, as I said, and Professor Paha mentioned that, and Ítalo as well. They're not applied at the same time, and they're not applied together. So it is compatible with all products of the PIC list. We have compatibility tests carried out, and it's a product that brings sustainability together with profitability to the market. Now, talking about PIC list, we do have this product within the integrated management concept, and it can be mixed with other products. And the analysis or the observation of such mixture can be done in a very simple way. There is a tool in our website where we just enter the tab compatibility, or you can use an app that you can download from Google Play or App Store. You just type there Koppert, and you go to Koppert compatibility. It's self-explained. And you click, for example, Challenger here, that is the case, and you see the active ingredient in the PIC list, and you click there. You can have green compatible, yellow moderately compatible, and red cannot be mixed. Very simple, simple as that. And then again, very briefly, this is all I'd like to say, and thank you again for your attention. We are at your service for questions you may have. Thank you.